Yes, that is indeed the central theme of today's session, which is focused on the development of applications that utilize artificial intelligence or AI within the Domo platform, specifically in the context of the Domo environment. We are planning to conduct approximately 7 demonstration sessions, each of which will showcase different aspects and features. By the way, as a point of reference, today is November 27th in the year 2025. Some of the demonstrations that we will be introducing and presenting to you today are actually beta version functions of Domo, meaning they are still in the testing phase and may be subject to further updates and improvements. So we would like to take this opportunity to introduce those beta features as well. The main purpose of today's demo session is that most users of Domo are already quite familiar with business intelligence or BI-like usage and are accustomed to using other BI functions. However, we would like to introduce a different side of Domo, one that goes beyond traditional BI, and give you a broader idea of the various types of usage that can be achieved, including those that incorporate artificial intelligence. As for how we will proceed with today's session, I'm not entirely sure if we will be able to fit everything into exactly 1 hour, but we are aiming to make it about an hour long, give or take a few minutes. First, we have prepared 7 different demos, and in order to realize and demonstrate these demos, we will introduce several of Domo's side-by-side functions, which are features that can be used in conjunction with each other. We would like to explain what each function is, provide a brief overview, and then actually demonstrate the 7 demos in practice. So we appreciate your cooperation and attention throughout the session. Now let's get started right away. First, there is the app function, which serves as the dashboard within Domo. With traditional dashboards, you would typically display charts on cards, and it was mostly used for business intelligence purposes. However, when you use the app function, you are presented with a new screen. In App Studio, you can display cards using a drag-and-drop interface, which makes it easy to arrange and customize your dashboard. You can display charts and cards, and there are also forms and various other functions available. It's almost like creating your own custom application using drag and drop, which is a very intuitive and user-friendly way to build dashboards. You can think of these functions as enabling application-like usage and app development within the Domo platform. These new and enhanced functions have also been added to Domo, so please make use of them to enhance your own workflows. Next is the Forms feature, which is also incorporated into the app function mentioned earlier. With Forms, you can enter data directly into the system. In this example, it's a survey form, but you can use forms for many different purposes. You can make new entries in a dataset or even start a workflow based on the input data, which adds a lot of flexibility and power to your applications. Next is ProCode, which is another function that is incorporated into the app. Domo is basically a no-code platform, which means you can build applications without writing any code, but it also supports both low-code and pro-code development. When you're not satisfied with the capabilities of the no-code support, or if you want to create something more elaborate and customized, there is a function called pro-code that allows you to write your own code and extend the platform's functionality even further. In summary, today's session will cover a wide range of features and functions within Domo, from basic dashboard creation to advanced app development using AI, forms, and pro-code capabilities. We hope you find the demonstrations informative and inspiring, and we encourage you to explore these features in your own work. Thank you for your attention, and let's continue with the session. These are web standard technologies. Many of you may have experience developing homepages or websites, and you can use technologies like JavaScript, HTML, and CSS to develop apps and incorporate them into the app we mentioned earlier. When using ProCode, Domo also provides JavaScript libraries, so you can access Domo datasets and so on from there. These libraries make it easier to connect your custom applications to the data stored within the Domo platform. Next is App Catalyst, which is currently in beta. To explain, as I mentioned earlier with ProCode, this is a generative AI feature. For example, if you consult with Domo GPT and say, I want to make an app like this, Domo GPT will create a draft for you. We call this App Catalyst, and although it's still in beta, you can try it out if you're interested. At the moment, it doesn't create a perfect app in a single prompt, but you can use the draft as a base and make adjustments as needed. Next is the brief workflow. From the perspective of business process automation, there is a workflow feature, as you can see in the screenshot on the screen now. You can do a wide variety of different things with this system, such as, for example, triggering workflows based on a specific scheduling configuration, or starting a workflow automatically when an alert is triggered after exceeding a certain threshold value. It's not just about automating routine everyday business processes. You can also integrate seamlessly with a range of external services, enabling that kind of automation as well, which can be extremely powerful and flexible. Next, let's talk about the code engine. Within the workflow interface, for example, you might see icons like this one, which is labeled Domo. There are a number of standard features and functionalities that Domo provides out of the box, but if you find that you need something that's not available as a standard feature, you can make use of the code engine. Think of it as being similar to Excel macros. In other words, you can create your own custom functions and logic to suit your specific needs and requirements, giving you a great deal of flexibility and control over your workflows. The supported languages are Python and JavaScript, specifically server-side JavaScript running on Node. You can use either one, whichever you prefer, whether it's Node, JS, or Python. If you create a function in advance using the code engine, as I'll explain later, you can call and use that function from within a workflow. And if it doesn't exist, you can just go ahead and make it yourself. Next, let's talk about AI agents. The official name is Agent Catalyst. You can incorporate AI agents into your workflows. What's interesting about AI agents is that while you define what kind of role the AI agent has through prompts, like specifying, you are this type of AI agent, that's not all you can do. You can also configure which datasets or file sets the agent has access to, and in the tools section, you can define which functions the agent is allowed to use. With these settings in place, the AI agent can then carry out its tasks accordingly. That's the general idea. It's quite interesting, so I'll show you later. Next, about AppDB. When it comes to datasets, there are often limitations on the number of characters you can store in a single record or column. Besides datasets, there's also a database feature called AppDB. This is a database where data is stored in JSON format. When you store data here, you can use JSON, and even if you have a large amount of text, you can store it without any issues. For those of you who often work with APIs or web APIs, you probably know that responses are usually returned in JSON format in the response body. So for programming languages like Python or JavaScript, it's easy for us to parse. And I think it's a very user-friendly format. Next is the FileSet feature. This is still in beta, but with FileSets, you can handle various files, CSV, HTML, PDF, or pretty much anything. It's a large-scale solution for handling unstructured data, so to speak. There's an area in Domo where you can manage these files as file sets. And it's not just about uploading files. You can also add indexes, or what we call works, to them. This work feature is quite interesting as well because you can add vector indexes. The files you upload are automatically vectorized. The files are indexed in this way, and this is the foundation for the currently popular RAG, Retrieval-Augmented Generation technology. In other words, instead of searching by keywords, you can perform semantic searches. I'll show you a demo of this later as well. Next, there's a new feature called Magic ETL AI Text Tile, which is also in beta. Basically, within Magic ETL, it is now possible to embed generative AI features directly into your workflow or application. For example, the icon with a pencil and a star mark, which you may notice in the interface, indicates a generative AI tile. This tile is a special feature that allows you to interact with AI in a more dynamic way. You can enter a prompt, which is essentially a question or instruction, and specify in detail how you want the AI to make judgments or decisions based on the data you provide, etc. In this example, it's an online survey review, and you can ask the AI to determine whether the written feedback is positive, neutral, or negative, among other possible categories. There are various things you can do with this feature, so I sincerely hope you'll make good use of it in your own work. Next, let's move on to AutoML, which stands for Automated Machine Learning. This is more closely related to the field of data science. Up until now, we've been talking about generative AI and large language models, often abbreviated as LLMs, but this next topic is about machine learning in a broader sense. So, what exactly is AutoML? It's basically the automation of the machine learning process using data, which can save a lot of time and effort. For example, it can be used for demand forecasting of products at each store, helping businesses predict how much of each product they will need, and so on. AutoML can also be applied to many other scenarios, such as customer segmentation, sales prediction, and inventory management, making it a versatile tool in the world of data-driven decision-making. When you want to create a prediction model, for example, in the context of business analytics or retail forecasting, you probably have a lot of past sales data for each store, for example, covering various time periods, product categories, and locations. You first need to clean up and organize that data, which means removing any errors, filling in missing values, and making sure the data is consistent and reliable. After that, you add feature columns, which are characteristics or attributes used for training the model, such as the day of the week, promotional events, weather conditions, or store size. You also need to attach the answers, or what we call labels, to each data point. Labels are the actual outcomes you want the model to learn to predict, such as the number of units sold or the total revenue for a given day. Once you've prepared the data this way, you pass it to AutoML, which stands for Automated Machine Learning. There are many different machine learning algorithms, such as decision trees, neural networks, and support vector machines, but AutoML will try out various algorithms and suggest which one works best for your specific dataset and problem. The prediction model you create can then be deployed to Magic ETL, as shown on the right side of the screen. Magic ETL is a tool that allows you to automate data processing and integrate your model into your data pipeline. This allows you to actually use it for inference, such as demand forecasting, predicting future sales, and similar applications, enabling data-driven decision-making and operational improvements. Next is Jupyter Workspace. At this point, we're fully in the world of professional coding, and it becomes a Python execution environment. This is also available on DOM and can be used for machine learning, but unlike the earlier AutoML, since it's Python, you have access to a wide variety of libraries available worldwide, not just those related to machine learning provided on Python, but you can also leverage assets created by researchers and developers from all over the world. Really smart people. That's one of the great things about Python. You can stand on the shoulders of giants, so to speak. So when you're doing machine learning, you can use various machine learning libraries, define the columns used for training in detail, and it's much easier to individually tune and customize things compared to AutoML. Prediction models created and developed within the Jupyter workspace, specifically on the Python side, can be deployed to AI projects on DOM. This process is similar to the workflow you might know from AutoML, where models are trained and then deployed for use in different applications. On the other hand, AI models you create independently within Magic ETL can be used as inference models directly on Magic ETL without extra deployment steps. That wraps up the feature introduction for now. At this point in our session, we've already spent almost 20 minutes discussing these foundational concepts and features. Now, over the next 40 minutes or so, I'd like to walk you through these 7 demos one by one so you can see how everything works in practice. The first demonstration is about Store AIPL, which will give you a hands-on look at how these tools and models can be applied in a real-world scenario. This demo involves carefully analyzing valuable insights for each individual store and creating detailed daily reports, essentially generating comprehensive store-specific reports. So let's get started. This is the demo app screen. The lower part here is simply a standard business intelligence chart. For example, if you select a store, such as Roppongi, the report for Roppongi will be displayed here, just like this. The charts are also linked accordingly. So what this means is, in the background, the AI agent within the workflow is actually generating these detailed reports for each individual store every single day. The AI agent creates reports just like this, so you can easily imagine that every morning, each store manager checks this summary while preparing for the day ahead. They use this as essential material for making important decisions to take action in their daily work. Alongside that, they also look at various charts like these, which provide visual representations of the data. But if you just have charts, over time, people tend to stop looking at them, or some users might not know how to interpret them correctly or efficiently. So, by providing supplementary information, such as the detailed summaries created by the SCA AI agent, I think it becomes much easier and more straightforward to make effective use of the data. Of course, you can display this information within the app like this, making it easily accessible, and you can also have it automatically distributed every morning by email or automatically posted to Slack or Teams channels through the workflow, ensuring everyone stays informed. All of that is possible with the current system. As for how this is actually implemented in practice, the part of the report created by the AI agent is made with Procode, and the information here comes from AppDB, which is the database used for storing all relevant data. As I mentioned earlier, it contains information for 26 stores, such as Simple Style Roppongi and so on, covering a wide range of locations and providing comprehensive insights for each store. There's also Simple Style Ginza, for example, which is another notable option. This kind of detailed information is included, and the content displayed in the report earlier is already processed into HTML format within this JSON file. When you change the selection, the Procode system checks AppDB accordingly to ensure that the most up-to-date information is always being referenced. It works by retrieving information for the selected store. As for how this is actually implemented, here is the workflow. The process is, once a day, the contents of AppTV are cleared in a batch process, and then information for 25 or 26 stores is retrieved. For each store, the AI agent creates the report we saw earlier, repeating this process for the number of stores. Within this workflow tile, we're also utilizing the code engine, so I'll introduce that next. This icon here is my avatar, but this part wasn't a standard feature, so I created it with Procode. The parts that say things like Domo are standard features provided by the platform. This is the code engine screen, and as you can see, there are two functions. It's kind of similar to Excel macros, which you might be familiar with. In this example, I wrote it in Python. And since there are no input parameters, I set it so that there are no return parameters either. Once you set it up, it becomes available for use in the workflow here, making it easy to integrate custom logic. Next, I'd like to show you the AI agent settings. First, on the General tab, you specify what data to provide in the prompt. Here, the data for each individual store is input as a variable. If you look below, you'll see something like, you are an analyst with over 15 years of experience, and so on. And it also says you can analyze with SQL. At the end, there's even an instruction to store the results in AppDB in a specific format, ensuring consistency. That's the General tab. Next is the Tools tab, where you define what functions the AI agent can use. In this example, with Create AppDB document, the AI agent is tasked with registering data in AppDB. By adding tools, you can let the AI agent use standard features provided by Domo. And if a standard feature isn't available, you can also let it use the code engine we just discussed. If necessary, you can have the AI agent use custom tools you've created yourself, giving you flexibility. You can also open the tool's properties to add explanations about how to use each tool, which can be helpful for users. Next is the Knowledge tab. Here, you can configure which datasets or files the AI agent can access. In this example, there are two datasets, a monthly PL summary for each store and a detailed dataset. The AI agent is given access to both, allowing for comprehensive analysis. There's also a feature for testing or validating the AI agent. Here, I've input the store information for Simple Style Ginza. If you click Continue, you can see how the AI agent actually behaves and performs its tasks from here. Please note, this testing feature is especially useful for verifying that everything is working as expected. It started running now. For simple style Ginza, it's kind of processing things in the background, and right now an SQL statement is being executed. As you can see, it's running an SQL query and accessing the data sets we defined earlier. There are about 3 queries, I think. In the earlier prompt, I showed about 3 sample ways to call this. So based on that, the AI agent is now using the data returned from those queries to create a summary. This is how it's working right now. After that, the summarized content is converted into HTML format and then uploaded into AppDB. I think many of you are using inference models like ChatGPT or Gemini, and the same goes for Anthropic's Claude and others. But as you know, these processes do take a fair amount of time. Since they're handling a lot of different tasks, the AI agent is currently working hard to process everything. Please wait a moment. On average, it generally takes about 2 or 3 minutes for each individual task to be completed. As you can see, it's gradually starting to move along, progressing step by step, just like this. If you look towards the top of the screen, you can see that it's already making progress here, and you can actually observe the process as it happens in real time. It says saving to AppDB, and it's probably already registered in AppDB. So let's go back and check to make sure everything is working as expected. Right now, there are a total of 26 entries listed in the database, but if I refresh the browser page, it becomes 27 entries. 1 new entry has been added to the list. The AI agent has automatically attached the summary information and inserted it into AppDB in HTML format, making it easy to view and access. If you scroll down the page, it looks like this, showing the newly added entry in the list. The final output section appears like this, displaying the results in a clear and organized manner. The analysis information is inserted into AppDB in HTML format, and the app retrieves that summary information for display. So this is just one example, an introduction to one way of using the AI agent to automate tasks and manage data. That concludes the first demo. Since there are a lot of sub-windows open on the screen, I'll close them to avoid confusion and keep things organized. Next, we will move on to the Domo Support Center, where I will demonstrate additional features and capabilities. The AI agent is fully integrated into the workflow, and we're also utilizing FileSets. So this will be a demonstration of what is commonly referred to as a RAG, which stands for Retrieval-Augmented Generation use case. This is the Domo Support Center app, but before we get started, let me take a moment to explain the setup a bit more thoroughly. Here is the file set. As you can see, it's a file set, and in this particular example, there are a significant number of CSV files stored, about 6,175 files in total. But it's not just that the files are stored. If you look at the index status, you'll see it says completed. The file set has a feature called AI search, and when that's enabled, vector indexes are automatically attached to the files, which enhances the search capabilities. If you click here, you can see the contents of the file. These are articles from the Domo Help Center, which have been converted to CSV in HTML format for easier processing. Since there are about 6,000 files, you can think of it as containing essentially all the knowledge from the Domo Help Center, making it a comprehensive resource. Using semantic search, it pulls up the most relevant matches and then sends those to Domo GPT, which generates answers based on that information. So, since this is RAG, it basically uses both LLM and FileSet technology together. Let me show you how it works in practice. First, there's the RAG chat. You can ask any question about Domo. For example, I just asked about the write-back connector. See, based on this text, the AI search feature performs semantic search to find the most relevant matches. Right now, it's searching and retrieving the top 6 most relevant results, and then Domo GPT generates an answer based on those. The answer comes back like this. As you can see, the process is seamless and efficient, providing you with accurate and relevant information in response to your queries. This integration of AI search and Domo GPT within the FileSet framework exemplifies how advanced retrieval-augmented generation can be leveraged to enhance user support and knowledge discovery within the Domo platform. I asked a question regarding the write-back connector. If you display the search results just below here, you will see the CSV files that match this question with a high degree of relevance. it shows 62%. They are all 62% ranked in order of relevance. This means that each file has been evaluated and given a relevance score of 62% based on how well it matches the question I asked. These are the files that matched. They're displayed here, and based on that, Domo GPT generates its answers. Also, if you scroll down, you'll see links like these. If there are CSVs in the file set or within a file, you can extract them. And by clicking, you'll be taken directly to the actual Domo Support Center article. This is another way you can use it. So this is one example of how to use the chat feature. Of course, you can also use chat directly within Domo. But I thought just this alone might not be that interesting. So I created a more advanced example of chat usage. This uses the form feature I introduced earlier. If you submit a question or inquiry about Domo through the form, sorry, I have too many tabs open. Here it is. In the dataset called Domo Support Log, the questions that are submitted through the form are stored one after another, so it functions as a support log, keeping a chronological record of all inquiries. For example, I've prepared 3 workflows to demonstrate how the system operates. The first one is as follows. When a new inquiry is posted, the workflow is triggered in this manner, and the AI agent creates a draft response, which is then stored in the dataset for further review. This workflow doesn't go as far as sending the response, it just creates and stores the draft, allowing for later evaluation. For the drafts that have been generated, there's another tab specifically dedicated to those. I've created an app called Response Draft Review and Approval. It's still under development, but the idea is that if you're worried about sending the AI-generated response as is, you can use a process called human in the loop. A human reviewer can look over and make some edits to the AI-generated content, and for example, after approving it and pressing send, the second workflow is triggered. Since it's been approved by a human, the workflow sends the response via email to the intended recipient. We've prepared this workflow as well to ensure proper communication. The third workflow depends on the specific use case, but for example, if it's communication with customers, it might be better to have a human check and approve before sending to ensure quality and appropriateness. But for inquiries from other internal departments, you could have the AI generate the first response and send it as is, labeling it as an AI-generated reply, and proceed directly to sending without additional human intervention. This flexibility allows the system to adapt to different scenarios and requirements, ensuring both efficiency and oversight where needed. You can also just go ahead and do it, right? So the AI agent settings for workflow 1 and workflow 3 are pretty much the same. So I'd like to actually show you a demonstration of this together. So this is the settings section. If you go to this part, it's basically the same as the general tab from earlier, and you can provide data here. For example, information like the case ID included in the support log and various other pieces of data from the dataset are attached. Then there's an explanation like, you are the AI in charge of drafting the initial response at the support center. It's like telling the AI, work in this role. That's how it's defined. So it's like this. And then regarding the support log, we've set it up so that it can also access the file set from earlier. So basically what this means is that the support log dataset contains the interaction history with the user, keyed by the case ID. Since a ticket usually isn't resolved in just one go, the AI can refer to that history while also... I'd also like you to take a look at the knowledge base. Yes, that's right. You can also access the dataset support logs as well as the file set from earlier. You can access the knowledge base too. So this demo is set up so that you can review email exchanges and at the same time access the knowledge base to formulate your responses based on that information. In this example, we're not really using any particular tools, but I'd like to show you a bit of how this works. So for example, the body of the email, the case title, and so on. Things like contact email and various discussion topics are included here. Ideally. But as you can see now, the AI agent is about to start working. The SQL is running again. It says SQL here. It looks like it's accessing the support logs from earlier. Now, this time it's the file set. I think it says file set query tool. It's also accessing the file set, and well, it's basically the same mechanism as the support center chat from earlier. This time it's set up to fetch the top 3 results, like bring me the top 3. It grabs the top 3 matches, the ones in red, and uses those as a basis. It uses those to generate the content of the email reply. So just like this, the AI agent creates the content of the email reply for you in a seamless and efficient manner. That's how it works. Yes, so this is the second way to use the AI agent, which I wanted to present to you. All right, so this is the second demo. There are quite a few tabs open, so I'd like to start closing some of them. Let's close this one as well, okay? That was the second one. Now, moving on to the third. This time we're at a hedge fund, and instead of generative AI or AI agents, I'd like to talk about traditional machine learning, things like AutoML and Jupyter. So, well, in a word, well, I think it's a pretty cool demo name for a hedge fund, at least that's what I think. To explain, this is a demo that compares which has higher stock price prediction accuracy, a model trained with AutoML or a model created in Jupyter. That's basically what the demo is about. As for myself, I haven't really done much machine learning, but about 2 years ago, while working, I was attending a night graduate school. That was about 2 years ago. Well, I only took machine learning classes, that's about it. Then this August, I joined the company, and since I had always wanted to try out machine learning, I decided to give it a shot. I think it's a really interesting field. All right, so about the content. First of all, there's a service called jQuants, which provides an API. This service allows you to obtain all sorts of information via API, such as stock prices and financial data for each stock listed on the Tokyo Stock Exchange. I'm currently trying it out with the Lite plan. For example, you can get a list of all listed companies and also daily updates from the stock exchange. You can obtain all sorts of information, such as stock price data, when the earnings announcement dates are, and the details about financial information. All of that is accessible. Well, since there was not a connector like this JContents connector among the available connectors, I wrote some Python code in Jupyter to access this information. You can get things like financial data, acquisition by investment division, upcoming earnings announcements, and 5 years worth of topics data, including daily stock prices. There are about 3,000 to 4,000 stocks, and even for 5 years worth of data. There are approximately 5 million individual rows, and all of that is carefully stored in the dataset. We retrieve and store it every day. So the data we collect ends up in the dataset like that. So in this way, before doing machine learning with things like AutoML or Jupyter, you inevitably need to process the data. That's where feature generation comes in, as shown here. We create ETL workflows for this purpose, and for each type of data, like stock price information, trading calendars, topics, and so on, we collect them in this manner. We also gather things like scheduled earnings dates and lists of listed stocks, and then we process and transform all of that data. We end up integrating everything into a single unified dataset that now includes the added features. As for the features themselves, well, features are basically the tendencies or patterns that you want the machine learning model to learn from. It's like saying, please learn from these kinds of trends. For example, information about the financial closing date, or things like the 5-day moving average, or the moving average stock price, and so on. Various such things. I tried adding a lot of these features with some ingenuity, yes. So here we have a data set with those kinds of features added. And then in the next data set to these features, furthermore, this time, within machine learning, well, this is supervised data. Since we're predicting stock prices, we attach the supervised data together. And then I guess you could call it regression analysis. And basically, we're using that kind of model to perform machine learning. Since it's stock price prediction, this time we're looking at 3 types. The return and stock price 1 day later, the stock price 5 days later, and the stock price 20 days later. Well, that's 20 business days to be precise. So it's like we're trying to predict those values. It's set up as a demo. So, well, the labels, those are the correct answer data. Based on actual past data from a certain number of days later, we attach the answer, like what the return was at that time, and use that for training. That's the setup. So that's about the training data. So finally, as for the supervised data from earlier, once we've prepared the labeled data from here, so this is where the actual training begins. This is the AutoML screen. Within the dataset, there's a feature called AutoML. So first, when you want to use AutoML, you can't really fine-tune things like specifying use this column, and this column as features. Once you provide the data, AutoML tries various algorithms based on all of it and creates a model telling you which one performed best. So if you need to do any filtering beforehand, like I mentioned earlier, instead of just handing over the dataset you created as is, if you want to display various columns or apply filtering, for example, you can create a view based on that. What do you call it? A view, right? You can create a view and then apply AutoML to that view. I think that's one possible approach. Here, this is AutoML. Well, I believe there were already about 5 million rows, but this is something that's already been executed. And the features here refer to feature quantities. It shows which columns were most useful as features. Also, various models like XGBoost or MLP and others were tried, and it displays something like Model 9 is recommended. So let's try something like retraining. I'll show you briefly, just for a moment, but it looks something like this. You select the answer label, basically which label is it? And if you leave the algorithm setting on automatic, it will try out various options for you. For example, in stock price prediction, you would probably choose regression. If you select regression and start, it will try out different algorithms that belong to the regression category. That's the general idea, I think. And then, well, if you've decided on this model, you can deploy it to ETL right away, just like this. And here, so honestly, it works like this, but within this data science tile, there is an AutoML tile. You can use it by dragging and dropping, and this is the prediction model we just created with AutoML. The prediction model you made is selected here, and based on that, you can perform inference. In other words, the inference phase, not training, and then predict the stock prices. That's how it works. You can do this using the AutoML tile within the data science tile. All right. Next, well, then I'd also like to briefly talk about the Jupyter side. This time I tried training a model on the Jupyter side using the same data set and the same features. For AutoML, it ultimately uses an algorithm called XGBoost, but for machine learning on the Jupyter side, this time I used LightGBM, which is it's a similar type of algorithm in the same category as XGBoost. I thought it might not be very interesting to use exactly the same algorithm, so I chose this one for this time. With Jupyter, since it's Python, it's easier to make detailed settings and do fine-tuning. For this time, I kept it very simple using just one light. I'm currently just training it with LightGBM for now. But since it's Python and there are so many machine learning libraries available, I'd like to gradually make improvements when I have more time at this stage. That's how it is. So next, the thing is, yes, that's right. The prediction model I created in Jupyter, the model built with machine learning, can actually be deployed on this platform. There's a feature called AI projects. Here, you can actually deploy the model you've created. You can deploy the model you created yourself onto the Domo platform. And ultimately, this is what happens, just like before, in the same workflow on Magic ETL, but this time is with the AI service. Within the AI service, there's this AI model. There are tiles for the AI models, and these three here are the models for predicting returns one day ahead. So there are three models, and here you can actually select the model you created yourself. And just like before, run inference to make predictions. So whether you use AutoML or Jupyter, once you've built your model, you can deploy it onto Magic ETL. This is how you can make use of it for your needs. Once the training is finished, you can integrate various results, such as the prediction outcomes, mass emails, and so on. Also from Jupyter, all the prediction results and everything are integrated. And then finally, after the data as well, the data is processed so that it can be displayed as a chart in the app. What you see displayed in the app is this right here. That's right. So in terms of how to read this, on the left is Jupyter and on the right is AutoML. The direction accuracy rate, did it go up? Did it go down? Basically, it's the accuracy rate, and then there's the prediction error, which is, well, the prediction error refers to the difference between the return rate predicted by the model and the actual return rate. In this case, the smaller the value, the better. Since we haven't specified any particular stock, there are about 4,000 stocks, but we're displaying the average values here. As for the prediction error, that's right. Well, I think Jupyter Lite, or rather the algorithm we mentioned earlier, seems to perform better overall. And in November, since it's been trained on about the past 5 years worth of data up until around mid-November, I think we'll only start to see its true predictive accuracy and actual performance with today's fresh data from now on. So in that sense, it's still ahead of us. But just as a test, well, shall we try selecting a stock, for example? Well, I've selected one stock. The dashboard here is still under development, but since I specified it by stock code, let's narrow down the period as well to make it easier to understand. I wonder if it's working, something like this. I'm getting bored now, so let's just pop up the chart and see what it looks like. Okay, so the blue line here represents the actual results. Right now, what we have is the closing price from November 26th. For Ryohin Keikaku, in this example, I think it's 3,144 yen, which is the actual value. From this point onward, AutoML and Jupyter are making predictions for the next 20 business days in this example. Up to this point is the current situation. Yes, and then, well, both are more or less following the predicted patterns that we have been seeing. Both have risen a bit compared to now, and the forecasts suggest they might drop a little in the future. But who really knows what will actually happen? I'm looking forward to seeing how it all turns out in the end. Yes. That's the end of the demo for the hedge funds, just briefly. And then, well, as you can see, things like this. Accuracy by industry, or rather the accuracy of the predicted direction, things like that as well. How should I put it? Well, yes. So there are things like the prime market, the standard market, and the growth market. And here we show the accuracy of the predicted direction for each. For example, in the banking sector, within the prime market, it seems relatively easier to predict the direction of stock prices in the prime market. That's how it is, yes. For now, well, just a bit. What's important is how the predictions will perform going forward. So yes, I'd like to keep watching this closely. So that was the third demo, which was about the Dome hedge fund. The next ones, 4, 5, 6, and 7 aren't as heavy. So I'll go through them quickly. The fourth one is a demo on metadata generation. So basically this data set here, this data set is a list of stocks listed on the Tokyo Stock Exchange. Did you know that there's actually a feature that allows you to include AI metadata within a dataset? If you look at it from that perspective, it gets added like this, but basically what this means is that for each column, you can manually write a description explaining what kind of column it is. This serves as reference information when AI accesses and analyzes the dataset, which helps improve the accuracy of the AI's analysis. That's the idea, just like this. And well, originally with this kind of thing using AI, ideally, I would like the meta information to be generated automatically as well. But since this is SaaS, I think that kind of feature will probably be updated and added in the future. However, even now, if you use workflows and such, you can actually do it. This is a workflow that generates metadata, and this here is something I made with Procode. So basically, I've only created this UI part. The process goes something like this. There's an explanation here saying that you can execute it. On the right side, I've embedded a form that launches the workflow, and under choose dataset, well, you select the dataset from earlier. Not only can you add metadata for each column of the dataset, but you can also add a description for the dataset itself. If you set this to true, that's the function it enables. And when you submit, it shows success, right? See, when it says success, let me show you how it actually works. Well, here in this auto race section list, you can see it's marked as in progress. And if you display it, you can see that it's currently running like this. You can actually see the workflow as it's running. You can see it, right? So just like this, it's currently in motion. For example, adding the header and the header description that's done with the text generation tile, and then it gets updated just like that. So I'd like you to take a look at the overview section here. As you can see, there's still no description in this part. When you refresh it, well, just like this, it gets updated with something like Dosan, this data set is, or this is about listed companies in Japan, etc. And for each column, for the number of columns here, it loops around and around in this loop and finally updates everything. So since there are quite a few columns, it takes a while. So for now, I think I'll just leave this as it is. Okay, I'll show you later. In the meantime, I'd also like to show you a demo of this data exporter. So basically, I tried using the App Catalyst feature as a test. What it does is, when you consult it in natural language about the kind of app you want to create, it generates a draft like this for you. Yes, so after creating the draft, I made a few adjustments, and this is what I ended up with. As for this data exporter, you can select a data set, and when you do, a list of data sets is displayed like this. If you want to change the order of the columns or something, you can do that as well. If there are columns you don't want to display, you can simply deselect them like this. You can apply selection filtering like this. Basically, this kind of filtering. Undo applies filtering by column as well. Then you can export it to CSV or Excel, for example. You can export it in this way. That's the kind of functionality it offers. And now, even for things that weren't originally available as standard on the road, for example, you can gradually create them using natural language like this. At present, it's still difficult to create something perfect with just one prompt, so you might need to make some adjustments based on the output or do a bit of fine-tuning at the end by hand. But as a starting point, I think it's really quite useful for that particular purpose. In my own case, I was able to create this kind of app in about an hour, so I sincerely hope you'll all give it a try as well. That's all from me. Thank you very much. It looks like it's complete now. So let's try refreshing this a bit. All right. As you can see, the metadata has been added like this. That's how it works. Yes. Now then, please stay with me for just a little longer. There are two things left. First, about the online survey. Well, it's more like a survey, or, it's something that uses the AI text style in Magic ETL. So let's say you have an online review like this. Here, the pencil icon represents the text generation feature within the AI services. Now you can embed generative AI here. What does that mean? For example, you enter a prompt, like in this example, you ask the AI to determine what language the online review is written in. Then you can have it add that information as data in a column called language, for instance. Also, for example, if the text isn't in Japanese, you can have it translated into Japanese, or you can analyze whether the content of a survey response is positive, neutral, or negative. That's sentiment analysis. And finally, you can categorize the content of the review, adding that information as well. All of these things can now be done using generative AI directly within Magic ETL. And well, since we're dealing with generative AI, even if you use the same prompt, the same data, and the same generative AI model, the output results will vary to some extent each time. This is just the nature of the technology. In such cases, if you want to normalize those output results or do something similar, you can add a tile like this. By doing so, you can observe the fluctuations or variations in the results, and normalizing them like this is one useful tip, I think. That's what we're doing. And ultimately, it ends up like this. For example, on a dashboard like this, you get a Japanese translated dashboard like this, something like this, for instance. Yes, now you can view a list of reviews like this. That's the kind of demo this is. Yes. There are actually quite a few cases like this. As a use case, it's pretty similar to the usage fees, and there may be a lot of similar applications, so I hope you'll give it a try. All right, now for the last part. This time, I'd like to talk about OCR Haru, specifically about OCR. So for this particular demo, well, I actually worked for a total of 4 years at an OCR vendor in the past. During that period, back then, large language models, or LLMs, hadn't come out yet, and they were not available at that time. Well, now that LLMs have come out, they've become capable of doing OCR-like tasks as well. So this demo was created as a sort of test to see whether things that are done with dedicated AI OCR solutions can also be accomplished here. As for actual use cases and such, I'd like to discuss and consider those together with everyone. First, this is the document analysis and structuring hub of the app. Here it is. There are all sorts of things: invoices, tickets, visa-related documents, and various other things. And then there are miscellaneous ones as well. There are all kinds of documents out there. So you run OCR on those and put them into a common a ledger. You put all sorts of things into a ledger like this. Information from various types of forms is stored in another data set, something along those lines. And the workflow that makes this possible is this one here. Is it really working as intended? Please go ahead. This is being accomplished with this workflow. As for the files themselves, they're stored here in this file set. For example, right, let me try to give you a sample. For instance, I recently went on a business trip to Hamamatsu and stopped by a Starbucks. So things like this, receipts, or when you take the Shinkansen, for example, things like this, Shinkansen, well, like tickets and such, you know what I mean? So there are things like this, or images, for example. I'll try running these through the workflow. I think it'll be easier to understand if I actually show you. All right. On the desktop right now, in the OCR sample, for example, I even tried it with Starbucks. Let's try it with the Starbucks one. I'll open it and run it now, the workflow. So just now, I think I selected a file. And when you select a file, if you refresh that file set from earlier, so this is image 1. It's been uploaded. Now it's been uploaded here, but actually inside here, there are subfolders within the file set, like invoices or receipts. They're divided into folders like that. With this workflow, from here on, we'll extract the information needed for OCR, and OCR is being applied here.